Vanakkam. In this session, I would like to discuss about memory management in C. The first part includes the introduction, then the automatic memory allocation, dynamic memory allocation, and static memory allocation. Memory is an array of bytes, and each memory location has an unique address. It is referred by the address value. That address is called as a pointer. The memory is one of the valuable resources which is maintained by the system. It needs to be handled efficiently. The memory can be allocated in three ways: automatic, static, and dynamic. The memory allocated has to be released by using the memory releasing functionality. That memory releasing can be done in two ways, either automatic or manual. Automatic memory allocation. The variables which are declared non-static and inside a function are called as automatic variables. Those variables gets memory allocation when the control flow enters into the function, and the allocated memory is automatically released when the control comes out of the function. That is, these automatic variables are stored in stack and they are not automatically initialized. The following program shows automatic memory allocation. In this program, it has three functions: the main, sum, and meml. In main function, a variable c is declared as type int. It is declared within a function, so it is called as an automatic variable. The memory for this variable is allocated when the control enters into that function. In main function, it calls a sum function. The sum function, it has two local variables, namely a and b. Now let us see the output soon. Here the memory allocated for a and b is 65518 and 65516. That sum function completes its execution. The control returns back to the main function. Here it calls the next function memall. In this function, it uses two local variables, namely c and d. The address for those two variables are same as the address for variables a and b. Since the automatic variable memory allocation takes place when the control enters into the function and it is automatically released when the control comes out of the function. The address used for a and b is used for the variables c and d also, because both are local variable. Their scope and lifetime is only within that function. It is not accessible outside that function. Then the next type of memory allocation is static memory allocation. Here the memory allocation takes place during the compilation time of the program. The variables that gets allocated by this type are global and static variables. Global variables means the variables which are declared outside all the functions. And static variables are variables which are declared with the keyword static. These variables are automatically initialized, and the allocated memory is automatically released when the program comes to an end. So the scope and the lifetime of static variables is throughout the program. The next example shows the usage of static variable. Here the variable g at line 4 is declared as a global variable. In the output, when I am printing the value of g from the main function, the g is 0. I haven't initialized at that line int g. Since it is a static variable, it is automatically initialized during the compilation time. Then in the function func, the variable c is declared as a static variable, I haven't initialized that variable, but while I am printing the value of C, its value is 0. When the first time it prints the value of C, with the value 0, after incrementing its value is 1. Then the control is returned back to the main function. Once again the same function is called. Now the value of C is 1, it is printed and it is incremented by 1 and it is next printed. Right? So the static variable, its lifetime is throughout the program. The next one is dynamic memory allocation. Here the memory allocation takes place during the execution of the program. The dynamic memory variables are not automatically, may or may not initialized. Memory size, that is based upon the request given by the programmer. The lifetime of the dynamic variables is the programmer's hand. Here the memory has to be explicitly released by the programmer. So for dynamic memory allocation, the programmer has to use some special functions like malloc, calloc and realloc. These functions needs a special library file, that is stdlib, standard library file. Here the functions used for memory allocation are malloc, calloc and realloc. For releasing, the free function is used. Now let us discuss about the memory allocation. All the three memory allocation functions will return a pointer, that is the address. The type of that address is void pointer. The void pointer means it can point to any data type. It is a general purpose pointer. Here in this example, suppose a variable pointer is declared of type void. It can have the address of a int variable, or it can have the address of a float variable, or it can have the address of a character variable. So this example, so the same pointer is used to have the address of different types of variables. The function malloc, the syntax for malloc is malloc, it going to take only one parameter, that is the size of the memory, that is the requested memory size to be allocated. Here it allocates memory and returns a pointer, a generic pointer. The memory allocated by using this function are not automatically initialized. Here the figure shows a variable, the memory allocated result of malloc function with requested size is 8 bytes. The variable A has the address of the newly allocated memory area. Here the example program shows the malloc function allocates 10 into size of int, that is it is used to allocate to store values of 10 int values. This memory is not automatically initialized, it is shown in the output. So for each memory area it has the different value, it is a garbage value, it is not automatically initialized. The next function for memory allocation is calloc. It takes two parameters, one for the number of blocks and another one for the size of each block. Normally this calloc is used to allocate memory for array variables. Here in array variable, each variable requires the same size and n number of variables we store. So those n and the size of each variable is stored. The memory allocated by using calloc is automatically initialized. We need to explicitly release the memory allocated by using either malloc, calloc or realloc. Here the example source calloc 10, 30. Here it requests 10 blocks of each size 30 bytes. So it totally allocates 300 bytes of memory and returns the first address of the allocated memory. In this program, it requested for memory of 2 blocks of each block is able to store 10 int values. So totally it allocates memory for 20 int values. Here all the values are automatically initialized. Since it is int, the values are initialized at 0. The next one is realloc. It takes 2 parameters. The first one is a pointer, the address, and the next one is the requested memory size. The first pointer is the memory which is already allocated. The second one is the requested size of the memory block. We use this realloc function to either expand the already allocated memory area or to reduce the already allocated area. The benefit of realloc is, suppose if we already allocated and stored some data in that memory area, and in future we want to expand, that is we need to store additional data. If we allocate the new memory with either malloc or calloc, it is not possible to have the data which we have already. So to retain the already existing data and extend the memory, we use the realloc function. It also allocates as per our requested size. If the memory is already having some content, that content is available in the newly allocated memory. The example, malloc of size 10. So here I have allocated 10 bytes. The next statement, realloc, requested for 50 bytes. So it extends the already allocated area. So it takes 2 parameters. The first one is the address which is already allocated by either malloc or calloc, and the second parameter is the new requested memory size. The example, malloc, here allocated memory for 10 int values. Those 10 values are stored in the memory which is allocated by malloc. So malloc, we know that it doesn't initialize the content. After using, suppose the programmer want to extend the memory area, they may call the realloc to extend the requested memory area. In this output source, so initially the values for the variable which is allocated by using malloc. After expanding, the same data are automatically retained in that newly allocated area. So from this, we came to know that the memory can be allocated using malloc, calloc or realloc. All the memory which are allocated dynamically has to be explicitly released by using the free function. The free function has one argument where the starting address of the memory block to be released. It just relinquishes the memory. So we need to explicitly assign null value to that pointer, or else that pointer variable has the address of the allocated memory area. Right? So the pointer is address of a memory location. We can allocate memory in 3 ways, either malloc, calloc or realloc. The allocated memory has to be explicitly released by using the free function. Thank you.